In this video, we are going to wrap up our work with multiplication, and we are going to start with some properties of exponents. So any of you who are planning on teaching 5th grade, that is where your exponents are going to start. Notice this is in the number, sense, and base 10 content band, so you're going to focus on powers of 10 because if you're multiplying or dividing by powers of 10, you are shifting your place value left or right. Now, once you get up into 6th grade, you're going to work on any number raised to a power, and you're going to use that in the context of order of operations. So just the definition, a to the nth power, that just means multiply a by itself n times, and a to the first is going to be a. And once you move into 7th grade, we're going to take the work that we have already done with exponents in 5th and 6th grade, and we're going to start working on the laws of exponents. Now, let me just warn you guys, this is not easy for the students. They're going to practice this again in 8th grade. They're going to practice this again in 9th grade, and it's just something that's difficult for them. So be patient. It's not that any particular rule is difficult. It's just that there are several rules, and they get them mixed up, or they mix up which order to do them. So it just takes a while for them to kind of get used to all the different things they're supposed to do. So look at this one. Theorem 9 tells us that if I am multiplying two numbers together, my base numbers are the same. My exponents are not necessarily the same, but my base numbers are guaranteed to be the same. Then when I multiply those together, what I'm going to do is I'm going to add my exponents. Okay, so one thing to be watchful for here, if you have, let's say, 3 to the 7th times 3 to the 9th, what you're likely to see from your students is 9 to the 16th. But notice that the a part doesn't change. So that should not be a 9 right there. What that should be is a 3. The exponents add together, but the base number does not change. All right, let's look at Theorem 10. In Theorem 10, I have a base raised to an exponent, and then I have that whole thing raised to another exponent. Well, if you think about what this means write a to the m n times and multiply them all together. Well, if I have a to the m n times, that means I have m times n a's. Whew, that's a lot to say. And so that is going to be my rule. When I raise a power to a power, I multiply my exponents together. Again, notice that the base number does not change. So if your student had, let's just use 3 again, 3 to the 7th to the 9th power, I'm going to multiply my exponents together. 7 times 9 is 63, but my base number does not change. It's just that now I have 63 threes that I have to multiply together instead of the original 7 threes that I had. Okay, let's look at Theorem 11. So this one changes a little bit. Notice now that a and b, the base numbers are different, but my exponents are the same. When that is true, I'm going to multiply my bases and leave my exponent alone. So you can see how the students would tend to get confused about this. Now I've got something that would be like 3 to the 5th times 5 to the 5th. And when I put those together, my base number changes, but my exponent does not. Exactly the opposite of what we saw before. Before, the base number stayed the same and the exponent changed. All right, let's look at Theorem 12. Okay, Theorem 12 goes very nicely with Theorem 9 over here. In Theorem 9, I am multiplying. I have the same bases. I'm multiplying together, so I'm going to add my exponents. So in Theorem 12, I have the same bases, only this time I'm dividing. So what do you guys think? If when I multiply, I add my exponents, what do you think I'm going to do when I divide? I'm going to subtract my exponents. And again, the base number does not change. So 3 to the 10th divided by 3 to the 6th, that's going to be 3 to the 4th. 10 minus 6 is 4, because notice my directions here. M is greater than N. We'll worry about what happens when M is less than N in future lessons as far as our 7th graders are concerned, not for you guys, but as far as our 7th graders are concerned, we're not quite ready to deal with those negative numbers with them yet. Okay, let's look at multiplication using expanded addition. We've had multiplication, writing word problems and various things like that. Let's look at some different algorithms for multiplying. So if you think about the number 367, and I write that using expanded notation, right? There's 367. and I'm multiplying 4 times this. Okay, so look, I've got 4 multiplied by several things added together in parentheses. So I can use my distributive property. I can just distribute the 4 across to each one of these, and that's what I've done here. Okay, well, it would be convenient if I could multiply these together instead of multiplying those together. So I'm going to use my associative property. Sorry about that. So we'll use the associative property to reassociate the original numbers together and move the powers of 10 off behind that. And now we can just use our number property. So we'll just multiply those together. 4 times 3 is 12. 10 times 10 is 100. 12 times 100, 1200, right? That's how I'm simplifying this line. And then we'll add them together. So final answer there, 1,468. And that might help your students understand why we put things in the position that we do when we multiply them together. Okay, let's compare that to the standard algorithm. Let's see what happens. So in this one, when I multiply together 4 times 7, that's 28. So I have an 8, and I'm going to carry it over. So let's see where we see that over here, right? So you guys can see the 28 that we have right here at the end. All right, now 4 times 6. Well, that's not really 6. That's really 60, right? So 4 times 60 would be 240, and I'm going to add not 2, but 20, right? Because I'm in the tens place. So when we think about this as 4 times 6 is 24 plus 2, we have to remember that all of that is happening in the tens place. So we really have 260. So I'll put my 6 and carry my 2. Okay, so let's look back over here. Well, look, here's the 24 and the 2 that we carried, giving us the 60, right? And then we carried over that extra 2. So 4 times 3, well, that's really 4 times 300, 1,200, and 200 more, 1,200 and 200, 1,400. And if I look back, there's my 1,200 and my 200 more. Okay, so everything that you saw in the standard algorithm and in the expanded addition method, they match. They're just a little bit, not necessarily in exactly the same place. Okay, let's try this one. So we're going to multiply this one out using expanded addition. So the first step was to write out the number using expanded notation. So that is 4 times 10 to the second plus 7 times 10 to the first plus 6 times 10 to the 0, right? Because you remember anything raised to the 0 power is 1. Okay, so now look back. The next thing I'm going to do is use my distributive property. All right, and I'm going to distribute that 5 to everything that's in the parentheses. Okay, now, next property up was the associative property. So I'm going to reassociate so that I have things that I can multiply together in the different place values. I'm kind of emphasizing the fact here that those numbers are in those particular place values because I haven't changed the tens. All right, so now we're going to multiply those together. Okay, so 5 times 4, that's 20. 10 times 10 is 100. 20 groups of 100, right? If I have 20 groups of 100, I have 2,000. All right, 5 times 7, that's 35. And 35 groups of 10, 35 times 10. You guys remember how we looked at this with the blocks and it groups everything to the next place value? Instead of being 35, it's going to be 350. And 5 times 6 is 30. Okay, so now let's add those together. 2,000 plus 350. I'm just going to use order of operations here. Adding the first two will give me 2,350. And if I add that to 30, I'm going to end up with 2,380. Okay, let's look at some end multiplication. We did front end estimation with addition. Let's do the same sort of thing with multiplication. So basically what's going to happen here is I'm going to adjust the way I'm seeing this. So the first thing I'm going to do is multiply 70 times 4, right? Because 7 is in the tens place. So 70 times 4, you're doing a lot of reassociation here. 7 times 4 is 28, and then I can multiply that by 10 to get 280. All right, well, if I've taken care of the 7 as a 70, now I need to take care of the 8. 8 times 4 is 32. Well, I pulled 78 apart to be 70 and 8, so I want to put them back together, and so I can't get that to let go. So 280 plus 32, we'll put those back together as 312. Okay, let's try this with this one, 93 times 5. So first step should be to multiply what? 90 times 5. All right, so in your mind, let's do that reassociation. 9 times 5 is 45, and 45 times 10 is 450. Okay, and then my next step, 3 times 5, and 3 times 5 is 15. So I took apart the 90 and the 3, and so now I need to put it all back together, 465. All right, on this one, notice that the what this is called has changed just a tiny bit. Instead of being front-end multiplying like we have here, now it is front-end estimation, because now I'm not going to get an exact answer like I did before. Now I'm just going to estimate and get one that's close. The process is exactly the same. You start multiplying with the first digit. So thinking of this not as 4, but as 400, 400 times 9, 3,600, right? 4 times 9 is 36, times 100, 3,000. Okay, now I'm going to multiply the next part. So for this one, I'll go to 70. 70 times 9. 7 times 9 is 63, times 10 is 630. And I'm going to add those two numbers together. So the reason why this is an estimate and not an actual multiplication is because I never did anything at all with the 4. I used these two numbers, and then I added those two numbers together, and then I just said this is going to be about 4,230. That's not the exact answer, it's just an estimation. Okay, let's do a little mental mathematics. Let's do some compatible numbers. So look at this one. This one, if you tried to do order of operations, would be quite challenging. 2 times 8 is 16 times 5, and then multiply that answer times 40. There's got to be a better way to think about this so that I can put some zeros in there and make it easier on myself. So how about if we use the commutative and the associative property to rearrange that? 2 times 5 is nice. That's going to give me a 0. 40 times 5 is nice because the 0 right there, and then 4 times 5 is going to give me an additional 0, and then I just have to worry about 8. So 4 times 5 is 10. 40 times 5 is 200. 10 times 200, because of all those zeros, 10 times 200 is not hard at all. That's 2,000, right? 10 groups of 200 would give me 2,000. And then 8 groups of 2,000, if I think about this backwards, 8 groups of 2,000 would give me 16,000. So if you just think about it as groups and things in groups, 10 times 200 is not bad. 10 groups of 200 is 2,000, and 8 groups of 2,000 is 16,000. All right, how about if we think about this as money? So 84 times 25 is quite complicated to do in your head. However, if you think about this as 25 being a quarter, it's a quarter dollar. Well, 84 is very easy to divide by 4. 84 divided by 4 is 21. So if I have 84 quarter dollars, I have $21. And these are not really quarters, right? These are cents, 25 cents. 25 times 84, I've got to think about that into cents. So $21 would be 2,100 cents because each dollar is worth 100